All right, good morning to everyone and welcome to the CitrusSprayEx application workshop 1. My name is Dr. Peter Akonlabi, Assistant Cooperative Extension Specialist in Agricultural Application Engineering with the University of California, Division of Agriculture and Natural Resources. And I am located at the Kenya Agricultural Research and Extension Center in Palia, California. I have been with the UC system since August 2018. This workshop will run today and tomorrow. It is part of our project sponsored by the Department of Pesticide Regulation entitled the Dissemination and Training for Citrus Spray Application Expert System Adoption in California. And I would like to acknowledge the other key persons on the project. My colleagues, Dr. Beth Grafton-Cadwell, Director of the Lynn Cove Research and Extension Center, and Dr. Greg Duhan, Cooperative Extension Area Citrus Advisor for Tulare County. I would also like to acknowledge the ANR Program Support Unit for their support in organizing and running this workshop. I would pass on to Julia to give us a quick information here.
Everybody, so I hope everyone can hear me. I just wanted to give a little update about DPR. So if any of you are needing credits for this time, we will have a final exam at the end of the 2 days. That link will be sent to all of you who are interested. In order to fill out, you'll have to get 70% on that exam in order to pass. And the end of that exam will ask for your license number. That way we can track who gets credit. And we are watching as throughout the entire time behind the scenes, so we know who's here and who's leaving early and all of that. So we'll be able to track your hours that way. If you have any questions throughout, you can email us at anrprogramsupport@ucanr.edu, and I'll put that in the chat box so that you guys can have that email address if you're having any problems. Otherwise, you can also chat us, and Peter's going to show you where that is here in just a second. Okay?
All right, thank you, Julia. Okay, so we would like to know who is here for documentation and reporting purposes. Please use the chat to introduce yourself. I know we have that information, but we also want to just double check. On your screen, I'm not entirely sure all that you can see, but at least I know you can see the chat. And then there'll be some other items that you either other icons that you can click to interact with us. Go ahead, use the chat, and please enter your full name and location. And I give you a few minutes to do that, a couple of minutes to do that, and then we can go on with the items for today. So while you complete that, I'm not able to see the chart at this point, so I don't know whether it's done, but I would assume that by now everyone would have entered, so I would move on with our agenda for today. So for today, we would, after this welcome and introductions, we would talk about the ABCs of spray application, and then look at calibration basics before our break at 11 a.m. We would have a 15 minutes break. And then when we return, I would give an overview of the CitrusSprayEx expert system, and then transition to our hands-on demonstration for spray application planning. And then for the hands-on demo, we would need each of you to have the CitrusSprayEx installed on your computer. And I assume that you have already done that. However, if you haven't done that, then I would suggest that you would use the 15 minutes break part of that to do the quick installation, so you would be ready for the hands-on work when the time comes. So I would ask to launch the poll 1, which is basically looking at your whether everyone has the program installed and ready to go. Okay, I think the poll is done right now, and we have about 2 people needing help. I would make myself available during the break if you need any help, but there is the video tutorial which guides you as to how to go do the installation. And I would want to point out that you would need administrative rights to do that. So if that is a limitation, then it will probably be difficult to do the installation. I think the poll is complete right now. I don't need to share this poll results, so we can go on with the next slide and move on with our content for today. Okay, so let's talk about ABCs of spray application. And here we would cover equipment, we'll look at operating pressure, liquid flow, spray volume and quality, air assistance, application timing, and application outcome. To begin, let's answer this $1 million question. That is, why do we spray? And the simple answer is this, that because we want to protect the crop. Because the idea of spraying is applying pesticides to our crop. The reason is to protect our crop. And in actual fact, that our crop is under attack. There is a range of enemies besieging our very important crop and threatening yield, profits, and overall sustainability of our food production. And here is a slide that I borrowed from slideshare.net, and it reads that food plants of the world are damaged by more than 10,000 species of insects, 30,000 species of weeds, 100,000 diseases caused by fungi, viruses, bacteria, and other microbes, and 1,000 species of nematodes. And in fact, this is a gloomy picture of the situation. However, various disciplines related to agriculture are involved in the fight against these enemies using different tools. And at the farm level, various methods are involved in what we term as integrated pest management. However, no matter your idea of integrated pest management, whatever the components are, the use of chemicals or chemical control, or to say the use of pesticides, always find itself in as a tool of last resort in protecting the crop. And for that reason, it is also very critical that pesticides are used well for an effective pest control the first time. Otherwise, we stand the chance of needing to repeat application and increasing production cost against the bottom line. So we need to learn more about how to do it right, so we can improve, or we can maintain effective application. And for us to be on the same page, we would need to establish some definitions here. Stay with me here. First, let's look at spray. The noun form of spray refers to liquid that is delivered in or driven through the air in the form of tiny droplets. So it is liquid, not gas. And spray is liquid, just that it is disintegrated into many tiny droplets. And the process of the process whereby this integration is achieved is called atomization. And this is achieved when liquid under pressure exits through an atomizer. And an atomizer is a device for emitting liquid as spray, an example being a nozzle. A quick definition here. A nozzle is a device having an orifice through which liquid exits as spray. And then we also look at the definition of pressure. I hope I'm not running through this quickly, but my intention is to bring us on the same page by running through these definitions. Pressure is a continuous physical force on the liquid by which it exits a nozzle, usually measured in pounds per square inch, or PSI. That is in American units, or say you can also have newtons per meter squared, or Pascal for metric units. And agricultural nozzles are usually rated at 40 PSI and color coded for easy identification and so forth. Now with this, let's take a moment and complete poll 2. It's a quick one here, and then we would move on.
Can everyone see it? There, go, great.
Yeah, I think it did. It started. I'll give a couple of minutes for others to finish up. Okay, the poll will be ending very soon. For those of you who have not taken, I'm encouraging you to do that right now. Otherwise, it would be ending soon. Okay, I think most of you have taken it. We have, okay. Now let's see the results of the poll. And we have, most of you were able to get the right answers here. Which of the following is a reason for applying pesticides? And well, it is the last resort used in IPM scheme to control crop pests, because you start off by doing all other things that would help to prevent and so forth, and use it as a last resort. And I think all of you had the two, and there are a few off once here in the question 3, a device for emitting a liquid as spray. Spray is not the correct answer because that is not a device. A pump is it's not the actual device that emits it as spray. It plays a role, but in this case, is the atomizer that does that that final conversion to spray. So, which of the following could be the correct scheme here? And I think one person missed it, but they should be fine. Most of you that responded got the correct arrangements. Okay. Thank you very much for this feedback. Let's move on. So, let's see. All right, so spray droplets in air are usually spherical in shape. And so the droplet size refers to the diameter of a droplet, which is measured in micrometer or microns. And for the same volume of liquid, the finer or smaller the droplet size, the greater the number of droplets. Similarly, the coarser or larger the droplet size, the lesser the number of droplets. And then furthermore, a higher droplet count also means that more area can be covered with a spray. And on the other hand, a lower droplet count means that a lower count means that less area can be covered by the spray. But also finer droplets present a challenge in that they are highly susceptible to drift loss from the application site. And this impacts the effectiveness of the spray application. So let's consider here droplets falling from a height of 10 feet. And we can see that 400 microns droplet can take about 2 seconds to fall. On the other hand, looking at 20 microns, this takes 4 minutes to fall through the same distance. So it means that we can put it this way, that the heavier, or the coarser the droplet size, the shorter time it takes to drop. So the smaller or the finer droplets will stay airborne longer than the heavier, larger or coarser droplets. Also at 10 feet high, a 20 microns droplet in a 3 mile per hour wind can travel about 1056 feet before making landfall. That is 1/5 of a mile. Whereas on the other end of the spectrum, 400 microns, droplet will travel only 8 feet before making landfall. So this also means that finer droplets can linger in the air longer, okay? Within the same spray, droplets range in sizes from finer to coarser, which means that you don't have the same size throughout. It's a range of size. So a representative droplet size is used to describe the spray quality. The typical one is what we term as the volume median diameter. or VMD. And in some literature, you can also find that DV 0.5. The VMD is simply defined as the droplet size at which half of the total liquid volume consists of smaller sized droplets and half of the volume consists of larger sized droplets. So here are some examples, and let's assume that our spray consists of exactly these four droplet sizes. And each of them is made up of 25. Each of them constitutes or is taking up 25% of the volume. So this is how it could look like. You know, the VMD will be a size between the middle droplets, because we can see this is taking the largest droplet that will take 50%. So the VMD will lie between the second largest and the third largest in this case. And then in this next example, the smallest size is made up of only 20% of the volume. And the next size is 30% of the volume. Therefore, the VMD is the same. This is 50%, 50%. So it's the same VMD, but we can see that the final droplets has reduced in number because of the volume share that has reduced. So the VMD is the same for these two examples. So in this third example here, the smallest size, droplet size makes up only 15%. If you add up the percentages, the 50% mark will fall in the second largest size. So the VMD is greater than the first two examples. And the fourth example here also gives the same VMD as the third example. But the smallest size is further reduced here. It's 10% here and it's 15% there. So this is a representation of how spray quality can differ among different nozzles. So the distribution of droplet size varies from nozzle design to nozzle design. And this is how we can understand it. And the VMD, or the droplet size spectrum, is represented graphically by using a sigmoid curve or an S curve. Each of these curves represent spray from a different disc core nozzle. And here the D213 is the smallest size, while the D646 is a larger size in terms of flow rate and also droplet size. And for these curves, the steeper the curve, the greater the percentage of fine droplets, and the smaller the VMD. On the other hand, the gentler the curve, the lesser the percentage of fine droplets. To find the VMD, we draw a horizontal line from the 50% mark on the 50% mark here to the curve, and then draw it vertically down to find the corresponding mark on the droplet size axis. So increasing the droplet size, in this case from D213 to D646, increases the VMD from about 140 microns to about 320 microns. Another representation is this. For the same nozzle, for the same nozzle size, and here we are considering D425, increasing the operating pressure decreases the droplet size. We can see this is 87 psi, which is this red one here, and then 218 psi. So you can see droplet size, the pressure is increasing this way, and the droplet size is decreasing. So this right figure gives a better representation. Is drawn from this. We can see that as we increase the operating pressure, the droplet size will decrease. Okay, let's take a moment to complete poll 3 and see what we have added. Can we put that up? Okay, thank you. I believe the poll is showing up now. We still have a couple of you to finish up the poll. Okay, we have one more. Would wait for that person to do it. Okay, we'll end the poll right now. Okay, so let's see. So I think most of you got it right for all the poll questions. So I don't know if I need to discuss this, but the one that I'll probably discuss is the number 4 and number 5, where a couple of you missed it. I mentioned that the volume median diameter is used to represent the spray quality, and also stated that the spray or spray from a nozzle usually consists of a range, a spectrum of droplet sizes. So the volume median diameter VMD is used to describe the spray quality. And other details which I did not mention here, we have instead of just a V, the DV is 0.5. We can also have the 90 percentile and also the 10 percentile to give a more detailed description of the spray. And then also here, number 5, generally decreasing operating pressure also decreases droplet size of a spray. It's the other way around. It's an inverse relationship. So when you decrease operating pressure, you would rather be increasing droplet size, and then increasing droplet size, you'd be increasing operating pressure, you'd be decreasing droplet size. So it's an inverse relationship. So the correct answer for 5 would be false, right? Okay, so let's move on to back to couple of definitions here. So let's look at spray or spray application. This is the application. So spray application or spraying refers to the to applying a liquid to a target in the form of spray. And a good example of the liquid for us here is what we are talking about, pesticide. And you can also have in a fertilizer, and in our case, the target can be a crop. If we are looking at, yes, we're looking at foliar application to the tree, for instance. And then if in herbicide application, we can also consider the target to be the weed we are trying to control. So then we have a sprayer. It's an equipment or device used for spraying or spray application. We know this. And then flow rate, I have already mentioned flow rate earlier on, but I did not define. So let's try to define it here. It is a volume of liquid delivered or discharged per unit time. And it's usually measured in gallons per minute, or we can also have liters per minute, depending on the units you are interested in. In our application, mostly we use the American units or standard units, and we have it in gallons per minute. Okay. So typically flow rate refers to what the nozzle is putting out, and let's consider these dots here to be nozzles of increasing sizes from left to right, and we see for the same time the droplet with a bigger size, or the bigger size nozzle puts out more volume than the smallest size nozzle. And then we can also consider this to be nozzles of the same size, but increasing pressure. So the volume discharge corresponds to pressure, and as we increase pressure, we increase the flow rate. So this brings us to the point where we consider one of the most important terms in spray application, which is the application rate. And it has to be understood within context. In its basic terms, it refers to the volume of liquid applied divided by the area covered, or the area intended to be applied to. And it is usually measured in gallons per acre. Or we can also consider metric units, and this would be in liters per hectare. Okay. And the volume applied can be obtained by multiplying the sprayer output, which is flow rate, which is a combined flow rate from all open nozzles. The multiplying that by time will cancel out the times and give us the volume applied. And then the area covered can also be obtained by first multiplying the swath width, and for tree crops, we'll be looking at the row spacing times the travel speed, and then times elapsed time, So we can cancel out the time to leave us with the sprayer output and then the area rate. We can term these differently. The spray output, again, is simply flow rate, and area rate here, we are referring to the land. So you can just make it flow rate over land rate. But the most important thing is whichever combination or whichever combination of variables, applicable variables that you use with the appropriate conversions, they should bring you to application rate. So in different literature or in different practices, you might find preference for one combination against the other and so forth. Again, the most important thing is whichever one you're using, you have to use it right to come back to the application rate, which is critical variable in spray application. So now let's look at spray methods and equipment. We have two main methods. We have area application and ground application. Although I'll be dwelling on air blast applications and so forth, my intention was to just focus on this briefly to give us some background. For the area application, we have fixed wing or rotary wing aircraft sprayer, and more recently, but quickly advancing, we have the unmanned aerial drones, unmanned aerial sprayers or drone sprayers, which are being used in some specialized situations. And then for the ground application, we have a boom sprayer, which works similarly as the aerial sprayers by applying spray downward from above the canopy. And then we also have air-assisted orchard or vineyard sprayers, which apply spray laterally to tree and vine crops. So these come in many different forms, such as we have a conventional air blast sprayer, and you have multi-role sprayers, and then we also have ultra low volume electrostatic sprayers and so forth. But air blast sprayers are the most common sprayers used for citrus and also other tree crop applications. So here we have other ground sprayers, like these backpack sprayer, backpack mist blower, ATV spot sprayer, and skate sprayer, and all other types that we can talk about. But these applies spray at a slower rate as there is some working involved by the applicator, so forth. All right, a quick poll here before we delve a bit more deeper and get through the ABCs of spray application. And then we'll be moving to calibration basics, as I have mentioned earlier on. So please complete the polls. The poll 4. All right. I think everyone has voted now. I would end it, and I think there was no deviation in this particular poll. So I don't need to discuss this one, but I would just end sharing the poll. And thank you for participating and providing the feedback. Oh, sorry. Here is the results. All of the questions were were addressed correctly, so I wouldn't go over explaining or discussing it. Okay, I would go ahead and stop sharing the results, and I would move on. All right. So a few more details here. For all these sprays that we have looked at, here are three major components you would find. We have a tank, which stores the spray liquid. We have a pump, which moves the liquid to an atomizer through which the spray is discharged. And then between these components are a range of other components that make a sprayer continue to function as it is supposed to. And we'll look at some of the details subsequently. Let's look at the pump. Sprayer pump sprayer pumps come in different types. Here are two common examples. We have a diaphragm pump and a centrifugal pump. The diaphragm pump consists of a diaphragm, which is pushed and pulled respectively by air suction. So air suction pulls, and pressure is used to push it. And the push and pull action draws liquid into the pump, and then draws liquid into the pump, and then out of the pump towards the atomizers. With a centrifugal pump, it consists of an impeller that turns as a drive shaft spins, and this action draws liquid from the tank into the pump, and then out of the pump towards the atomizers. Now, diaphragm pumps are an example of a positive displacement pump. We have other examples of positive displacement pump being piston pumps, and then we also have roller pumps. The pump output of positive displacement pumps is proportional to the speed and virtually independent of the operating pressure. So in order to prevent back pressure in positive displacement systems, a key component that needs to be in place is the pressure relief valve. Okay, and this requires proper placement and sizing of the pressure relief valve for a safe and accurate operation of the pump. And then for this, the centrifugal pumps are an example of non-positive displacement pumps. And the output from this type of pump is influenced by pressure. So this pump is ideal for delivering large volumes of liquid at low pressures. And a key component of the centrifugal pump is the throttling valve on the main output line. And that is essential for accurate operation and also of the centrifugal pump. Here is some plumbing diagrams. In this particular example is an aerial sprayer, but my purpose of showing this here quickly is to give you a sense that the plumbing system components are quite similar between aerial and ground sprayers. Okay. Here the spray liquid is drawn from the tank. It's drawn from the tank by an air-driven pump, and then pushed to the nozzles on a boom underneath the wings. And there are strainers in the line to sieve off debris, and also throttle, pressure regulator, control valve, and so on, as you would find also in ground sprayers. Here is an example of a plumbing diagram for agricultural sprayers. This particular one is a two-way plumbing diagram, and it includes a diaphragm pump, which, remember, it's a positive displacement pump. Now the liquid is drawn from the tank through an open manual shut-off valve here, and then through a line strainer where debris are removed before coming to the pump. And then from the pump, the line splits into two. One line is a spray line which goes to the nozzles on the boom here, and the spray line includes a flow meter, and then also a two-way boom control manifold, and then a pressure valve here that connects to a bypass line back to the tank. And then the other line this way also splits into three different lines. We have the agitation line, and we have the bypass line, and then we also have the tank rinsing line. And this diagram and subsequent ones that I would show briefly, these serve as a guide or guidance for plumbing agricultural sprayers. And in place of, here you have electric regulating valves shown, but in place of these electric regulating valves, we can also use manual valves. The only thing is that we need to maintain the sequence of the valve in order to ensure that the sprayer would work as it's supposed to work. Most common causes of premature valve failure here is due to improper installation. So it's important to take care of, follow the guide and stay on course. So here is another diagram. It's a three-way plumbing diagram, and this is also utilizing a diaphragm pump. And then we have a two-way plumbing diagram, this time utilizing a centrifugal pump. And this centrifugal pump, remember, is a non-positive displacement type of pump. And then another diagram using a centrifugal pump here. Here is what they term here as a flowback plumbing diagram. So there are all sorts of diagrams depending on which pump and what type of plumbing you want to do. So quick poll here, poll 5. Kindly complete poll 5 as it comes up. There are 3 questions for this poll. We still have a few people to complete, a couple of you remaining. Okay, I think everyone has voted now. So let's end the poll and see the results. A couple of differences here, so I would quickly discuss this. So the first one is, what are 3 major components you would find on every sprayer? And based on the slides that I showed you, Actually, A is what I was looking for. And if you look at sprayers in general, for B, you would not necessarily find a pressure gauge on every type of sprayer. There'll be a tank because definitely there has to be a place to store the spray liquid, and then some kind an atomizer to create the spray, but not necessarily as a pressure gauge. And then in that case, to here we see that we are missing something. There is no pump, there is no tank here. If you look at this one, so the most applicable answer is A. Okay. And then for question 2, for which of the following is the pump output proportional to the speed and virtually independent of pressure? This is where we talked about the diaphragm pump, which is a positive displacement pump. And I think most of you had that. The non-positive displacement pump is actually dependent on pressure. So it wouldn't be B, and definitely not C, because C is saying both A and B. So if it's not B, then it's not A and B together. So the most appropriate response is A, okay? And then for 3, it says, for which of the following is a pump output dependent on pressure? So it's just the opposite, the 2 and 3. So here, B is the most appropriate response. B is the most appropriate response. Thank you for participating. I'll stop sharing the results right now and move on. Okay. Thank you very much. Now let's delve closer and zoom into airbrush sprayers. Now here is a simplified schematic of an airbrush sprayer, and some of you might have seen this before if you've been in any of my presentations. Some of you have not. This is very simplified, meaning that there could be other components that you would not find here, but this is meant to show you, you know, most of the components that you would find, you know, in an airbrush sprayer. And so this is opened up, and so we have the tank here, which contains the chemical mix, and it comes with some kind of agitation. You can have a mechanical agitation, you can have hydraulic agitation. And then we have the pump draws liquid from the tank, and again pushes all the way, you know, to the nozzles on a radial or vertical boom. And there are all other components that belong to this plumbing. We have strainers, line strainers. Here is a suction strainer. Here is a line strainer as well. And we have, you know, pressure regulation here, and we have also pressure, a pressure gauge for monitoring and feedback, which is needed to ensure that the pressure, the amount of pressure in the line corresponds to ideal or desired pressure, and so forth. And there is also control valve to regulate flow of the spray liquid. Now the fan draws air and discharges the air with a spray, and the air serves as a vehicle for transporting the spray droplets towards the target. So you have the air and a mixture of air and spray going in one direction to the left, and then a similar one going to the right. We are familiar with this, I'm sure. So here is a conventional air blast sprayer with a typical polar jet design. And there is also, a stationary air blast sprayer, which you can see very clearly because there's something is blocking the view. It's standing right here. And we can see how the spray is being discharged. You can see how high and also how far from the sprayer the spray is traveling. Now, if I were to put a tree in the way of this what do you call this spray cloud, it would become our target tree, and we would expect it to capture the spray. Some of the spray will be captured by the tree. Some will, obviously, as you can see, some of the spray will get to the ground directly, or maybe indirectly through runoff from leaves and so forth. And then others would also miss the spray, the canopy. Here is a summary of the application process. The bulk tank mix is atomized while exiting nozzles under pressure into the air, which transports the spray droplets toward the target trees. And the tree captures part of the spray to result in deposition, which is our desired outcome. And the rest of the spray either drifts beyond the application or beyond the canopy, and thereby also possibly out of the application area, and some of the spray also gets to the ground. So this is the partition of the spray as after it's been released. And so by maximizing canopy deposition, we would minimize the losses. We would minimize ground deposition and potentially also minimize drift. And atomization, as we have said, results in a range of sizes of droplets in a spray. And here are the factors influencing the atomization or droplet size. We have physical properties of the tank, nozzle design, and operating pressure. These influence it. And then as the spray cloud moves, there is also the influence of weather factors. For instance, a high temperature combined with a low relative humidity would hasten droplet evaporation to favor drift. And we already know of the effect of wind on droplets. Okay. So this brings us to some considerations for a good spray application. And these factors would have to be considered together to result in a good and effective spray application. The operator or the crew plays an important role. The sprayer, the sprayer condition, and also the sprayer settings also play an important role. And the resulting spray plays an important role. The timing of the spray, the accuracy of the spray volume, the direction, as in directing the spray towards the target and not missing the target. All that would play an important role in ensuring that the spray that we are applying is reaching the target and potentially covering the target to our according to what we desire. And then another thing that I also want to mention is the fact that for the spray, it has to be optimized for on-target coverage and deposition. And what I mean by that is that when the spray reaches the target, it should be able to stick, it should be able to stay on the target rather than rolling away or being blown away, and thereby not necessarily remaining to perform the pest control. So let's take a moment to do this poll 6, and this would be our last poll for the ABCs of spray application before we move on to talk about calibration basics. We have a couple of people remaining to complete the poll. I'll give some time. Okay, few more seconds, and I think you would close the poll. Okay, I'll end the poll now. And I will share the results. Okay, so for the question 1, I wouldn't discuss that because it's clear and everyone that responded selected the correct or the expected option. For question 2, it says at any instance during an air blast spray application, meaning that while the sprayer is moving through the field, which of the following defines the target trees? And at any instance, the target trees are the trees adjacent to the sprayer in the immediate tree rows. That is the rows on the left and right that is the sprayer is applying directly to. Those are the adjacent trees. And so the ones immediately adjacent to the sprayer, those are the target trees. And these the process is dynamic. So as the sprayer is moving through the orchard, applying spray, the target is changing all the time. While it is possible for spray that misses the target to end up on some other canopy within the same orchard, so that is to our benefit. At that point, that particular canopy is not necessarily the target, but the spray that misses the actual target and landing on that canopy tends to favor the application in the end. But the actual target is the immediate trees that are receiving the spray, or that the spray is actually directed towards. And then question 3, it's obvious, it's clear, and everyone chose the expected option. Question 4, I'll discuss it briefly. Which of the following weather conditions should be avoided because of its effect on spray application? I would say high wind, which is C, is what we're expecting. High wind speed because it favors drifts. Okay. Someone or a couple of you chose A. I'll discuss that briefly. Says high relative humidity because it favors spray drift. Actually, it's not the case. With high relative humidity means that droplet evaporation rate will decrease, and that with all things being equal, that would not favor drift. The opposite would, when you have a lower relative humidity means that the air is drier, and for that matter, evaporation rate increases. That would mean that the droplet size will be decreasing much faster than when the relative humidity is higher. And so option A would not be the appropriate one to choose. So option C, and I'm glad that most of you selected that option C appropriately. Thank you very much for your participation. So this brings us to the end of the ABCs of spray application, and we would transition to talk about the next. We'll transition to the next topic in line, which is calibration basics, and we'll try to understand the formula, measuring travel speed, checking air profile, selecting nozzles, measuring spray output, calculating application rate, determining spray coverage, and also I said we'll look at how much pesticide is in the tank. I unfortunately did not include that in my slides today, but I can mention that, or I can pull that one up quickly when we come tomorrow, or if there is time, and we can also look at it today. But I don't see that there will be time to do that, so we can look at that tomorrow then. So let's quickly define sprayer calibration. So what is sprayer calibration? And I would say it this way: sprayer calibration is the adjustments made to a sprayer based on measurements taken to ensure that the correct amount of material, that is a spray mixer or target or active ingredient, is applied. So it involves measurements, it involves adjustments, and then it also involves verification and so forth. So there are calculations involved, and you measure to verify that those calculations are correct. So why do we calibrate? There are a number of reasons why we would calibrate, and I'll run through these quickly. First and foremost, I would say calibration is best practice in spray application, and any device that is meant to do something by design, the devices, or engineering engineering works drift, and so from time to time it is important to calibrate or readjust things. And for sprayers, it is critical to make sure that the sprayer is doing what you want it to do. So calibration is best practice, and has to be done. And when done correctly, meaning that you can do calibration incorrectly and thereby have erroneous results to work with. But when done correctly, it is a sure way to know how much of material you are actually applying, or you would be applying to the crop. And when you calibrating correctly, or if you do not calibrate at all, this can result in inaccurate application rate, because if it's off, you have no way of telling that it's off. And if you calibrate incorrectly and you are working with that, you might be applying more than you think you are applying, or you maybe applying less than that. So it is important to do it right. and it can result in inaccurate application rate and ineffective application in the end, and then also illegal residues on treated crops. That is, if you over apply. And accurate calibration will lead to this, to an effective pest control while minimizing waste and negative human and environmental impact. This could be debated to some extent, but if things are done right, considering all the necessary adjustments that we are going to look at, I think you should be able to improve or optimize the application. And then by also knowing the how much you're applying against the the pesticide label, you would also ensure compliance with the law represented by the pesticide label. So when are we to calibrate? And how many times? Ideally, at the beginning of the growing season, when things are a bit slow, or when for trees that are now going to get foliage and there isn't much activity going on, that's a good time to calibrate the sprayer and make sure that it's ready for the more active time. And so at the beginning of the growing season is an ideal time to calibrate a sprayer. And also whenever there is any significant change in conditions in the target. So for instance, if you are moving from one side of one section of your orchard to another section, and the ground conditions are different, it would be good to calibrate for both sides what needs to be calibrated. Maybe the ground condition means that you have to check speed for the same desired settings. You check speed to make sure that to know how it differs from one point to another, and use that to adjust the other components appropriately. So change in target condition, such as crop type, would need calibration, canopy size, for instance. And by canopy size, I'm also on the side talking about canopy density, and this is foliage density for crops that the foliage density would increase from 0 to full canopy cover later in the season. So these are changes that would require some kind of adjustment, and it's good to do calibration so your application is factoring in those changes. And although not all the steps may be necessary in response to a change, adjustments should be made to the components that are directly affected by the change, and that would help to. These are two main points for when to calibrate. And the fundamental concept also comes from what we have discussed. We looked at application rate, and when we calibrate, we are, at the end of it all, we are looking at determining what the application rate is, and that is what we are going to use. That is the target we are going to try to achieve in our application. So we have looked at the volume applied per area, which is the application rate, and we've talked about all of these different ways to approach it. This is basically the concept. You have sprayer output or flow rate, divided by land rate. So you are looking at swat width, which is row spacing for tree crops, and travel speed. These are important variables that needed to be known in order to determine what the actual application rate is. The simple relationship applies to all types of sprayers, because you are looking at how much liquid you are applying over what total ground area. The calculations, the computations involved to arrive at that may differ, but at the end of the day, that is what we are looking at achieving. So please, let's take poll 7 quickly, and after this, we would have, I think, one last poll as we move on. We'll give a few seconds to complete the poll. Looks like we have all the responses in now. Okay. Okay, so I'll stop the poll and share the results now. All right, I'll discuss a couple of these questions. I'll skip question 1 because all of you that responded scored, chose the expected response. So the question 2, it says, which of the following can result from incorrect calibration or not calibrating at all? All right, inaccurate application rates, that's definitely one. Ineffective application, that's definitely another one, potentially, and a reduced environmental impact. This is questionable because if there is a tendency to misapply, it means that the environmental impact, and here the idea is negative environmental impact, that would rather be increased or potentially increase in this case. And then illegal residues on the treated crop is possible, also because if incorrect calibration or not calibration at all is resulting in over application, this would be one of the options that we would expect you to select. So definitely it's not none of the above. Once one of these is selected, it can be none of the above. And then for question 3, definitely it's false. Sprayer calibration should not be done only at the beginning of the season. Otherwise, you miss some opportunity to improve your application. And then question 4, generally increasing land rate increases application rate. If you look at that relationship, land rate is the denominator, meaning it's the number on the downstairs at the bottom. So the relationship is inversely proportional to the application rate. So when you increase land rate while the flow rate or the sprayer output remains the same, you are going to actually decrease application rate. So, and when you decrease land rate, you are going to increase application rate. So the correct response or the expected response here should be false, because increasing land rate will not increase application rate. Rather, it will decrease application rate. And this is important to note when you're moving from one side of your orchard to another side. Let's say land rate. One component of land rate is row spacing. So if you are moving from a block with, let's say, row spacing of 22 feet, and then to a block where the row spacing is 20 feet, you are going to decrease the land rate. So by decreasing the land rate, you would be increasing the application rate. And vice versa, if you're moving from, let's say, 20 feet row spacing to to 18 feet row spacing, you would be decreasing the, if you move from, if you increase the row spacing, if you're moving from a smaller row spacing to a larger row spacing, you would increase the land rate, so application rate will decrease. And if you move from a larger row spacing to a smaller row spacing, you would decrease the land rate, so the application rate is going to increase in that case. So it's an inverse proportion here. Okay, I'll stop sharing the results and we can move on. Thank you very much for your participation here. So let's move on and see what steps are involved in sprayer calibration. And the steps that I have lined up here, you would find variances of it in different practices. And so I'm saying that this is not the only steps that you can find, and there are other measurements or other adjustments that other people may look for, or maybe other adjustments that they may leave out in their calibration. But these steps are adequate steps to give you a fully calibrated sprayer. So the steps are as follows. We determine ground travel speed, would determine, we assess air profile, and we are looking at air blast sprayers for citrus and also other tree crops, okay? So using, assessing the air profile to determine the number of nozzles required. So the idea is that the fact that the sprayer has maybe 10 nozzles on each side doesn't mean that all 10 nozzles should be open for a particular plot, but rather the number of nozzles should be selected to match the size of the canopy. So the number of nozzles determined, then they select the nozzles based on the number and your expected or desired application rate. We'll be looking at all those, and then measure sprayer output. Measure sprayer output or application rate. So sprayer output, and then use that to verify the application rate that results from that sprayer output. And some people would leave it here by measuring the sprayer output and determining the application rate. Now they know what the application rate is. So the pesticide amount that goes into it would factor in the application rate in order to achieve the active ingredient rate the actual pesticide rate. But if you are targeting a particular application rate, a particular gallons per acre, then after determining the application rate from the sprayer output, you would need to adjust the sprayer output, adjust it in order to adjust the application rate. And then once all of this is done, it's also good to assess spray coverage to verify if the settings, all the settings would help to achieve a desired output or outcome, sorry. So let's look at measuring ground speed. I'm not going to go through every single one of these, but the fact is there are many different ways to measure ground speed. A simple way is a manual known distance method, where you mark out a distance, a known distance, and then the sprayer will have to travel that distance, and you time from when the sprayer reaches the first point to when the sprayer reaches the last point, and that time and the distance will be used to calculate the speed. And one thing to note with this, with speed measurement, is that while observing the movement of the tractor or the sprayer, we need to choose a point, a fixed point on this combination that you would use to determine the speed. So let's say, for instance, if you choose the front of the tractor, when the front reaches the first flag, that is when you start measuring the time. And when that same front reaches the last flag, then you would end the time measurement. If you start measuring when the sprayer reaches the starting flag, and then you stop measuring when the sprayer the back of the sprayer reaches the last flag, you have erred in determining the time, because you would add a bit more time to the measurement, and that is going to reduce the speed that you calculate from your test. And then so that will thereby go to impact your calibration. So I mean, if you have more people to help with the measurement, with the ground speed measure, travel speed measurement, you can make use of the hands. But if there's also just one, maybe an operator, one person in addition to the operator, I mean, there are ways to do that. You can watch from one end and let the spray, the front of the tractor touch the first flag. That should be in the path of the sprayer. And then once it touches, this is the starting point, and once it touches, this is the end point. So when you start measuring here, and you stop measuring time there, and so forth. Another method is using a number of trees passed in an orchard. So you would let a sprayer travel, and then you start measuring. You will start You start measuring here, and then you stop measuring when it reaches here. But in actual fact, the distance that you would obtain would be one less of these counts. So when you count the number of canopies or trees, you would consider the first point where the flag is to be 0, because you are looking at the tree spacing you are putting the tree spacings together to get a distance. So the number of trees in this case would be 1, 2, 3, 4, 5, not 6, because this is 0. Okay. So, and then you can also use a GPS tracking to do that. The row spacing is center of tree to center of tree, and that is easy to get with a measuring tape. And then checking the air profile here. I mean, this is in Vine, but I just wanted to use a representation here for you to see. We can tie we can tie some flagging tapes to the nozzles to see, and then run the sprayer with the air to see where the flagging tapes pieces of flagging tapes will be pointing, and this will give you an idea of where the spray, the middle of the spray would be. So you can do that to determine the number of nozzles that would actually be directing the spray to the target canopy, and use that to select the number, the nozzle, note the location of those nozzles. And then once we know the number of nozzles, we can determine the desired nozzle rate by we can determine the number of the desired number of nozzle rate. And here is the computation we can do. If you are spraying from two sides, then we would use the gallons per acre times the miles per hour speed that we have obtained. And this gallons per acre is our desired application rate. This is the speed that we have determined the selected or desired tractor setting to give us in that field. And then this is a row spacing. Continuing from where we stopped, I'm going to run a little faster here. So we have the this formula to we have this formula for our to obtain the flow rate. This is actually the sprayer output, the GPM, two sides. The spray output, we have gallons per acre, which is our desired application rate, the speed, the row spacing. And if we are spraying from two sides, we would use this 495, and this is the combined conversion rate, conversion factors, which is this GPA, MPH, and then RS, row spacing in feet. So this is miles per hour, this is feet, this is gallons per acre. All right, and would obtain gallons per minute. If we are spraying from just one side, and some people do that, then we'll be using the factor 990, which is twice this, because then we'll have to multiply that by 2, and so we would have to that is half. So we have to factor it in, and this will give us 990, and this is from just one side. If we put in the values appropriately, regardless of which one you use, the gallons per minute would be per side would be the same. This would look at just one side, this would look at two sides, and so we can use that appropriately in any of these formulas, whichever one we choose to use. And sorry, the top one here is supposed to be two sides, not one side. Okay.
We have a question. What does the 495 mean?
The 495 is just a combination of all the factors. You are converting miles per hour. You have miles per hour here. You have feet here. You have gallons per acre. when you do the conversion from miles to feet, to use this feet, and then you have gallons per acre, the acre would also have to convert into feet squared. And so there is a cancellation of all those factors. I don't want to go into all the computations here, but it's just a combination of all the factors, the conversion factors from miles to feet, and an hour to minutes, and all those combinations here. If you do all the conversions and do the calculations, this would be the factor that would have to be put in to obtain the correct gallons per minute. So also one thing to factor in for the choosing the nozzle, the number of nozzles is when you have differences in nozzle size, canopy sizes. This would warrant the need to select appropriate nozzles, number of nozzles that would result in the spray being directed on the canopy. So we can't just use all the nozzles because we have we want to use all the nozzles. So the size of the canopy density, and all those will have to be factored in. And for lack of time, I cannot go through all of these here, but I would say the next step is actually selecting the nozzle. So once we have obtained the individual nozzle flow rate, we know the pressure, the operating pressure we want to use. So we'll use operating pressure to locate a flow rate that matches the calculated flow rate. And we would not necessarily have it to be exact, but the closest possible would help us to identify which of the nozzles would be able to get close to that flow rate. And so if the flow rate is that we get is a little lower than what we desire, it is going to result in reduced gallons per acre than what we actually desire. And if it's a little more, it's going to result in a little more gallons per acre. So then we would need to do some adjustments. It's similar here. We have this is disc and core. The other one is air induction nozzle. Same concept here. You're looking at the pressure and using that to find a flow rate that matches the nozzle that you are going to use. And then once we have obtained the nozzle, we actually have to fit these nozzles and then run the sprayer using the settings that we have identified to use, and then actually measure the flow from the nozzle, and so that we would verify if that flow is going to result in the application, our target application rate. And so these are a number of ways to do that measurement. We can use calibrate. We can run the sprayer in a fixed position and then spray for a certain period of time, say 1 minute, and then fill the spray, the liquid back into the tank to the level that we had from start, so that the amount of liquid that is used to fill it back would be what was sprayed out, and we can use that for the calculation. We can also use a measuring pitcher to do that by measuring from individual nozzles and checking and verifying what the flow rate is. And then we can also use automated means. There is this nozzle calibrator. We can use that, the spot-on nozzle calibrator. We can use that one to automatically determine the flow rate. And then there are other means that we can do this. And once we have obtained that, we would put that in here into the computation, and that would give us the gallons per acre. It's the same formula as the previous one. It's just rearranged to get the gallons per acre, the application rate again. And then we would see if that application rate matches what we started with as our target application rate. And then once we've done that, I've mentioned that some people would stay with that one and rather adjust the tank, what you call content. But otherwise, you can, if you want to stay on that same, the desired application rate, then you can do two adjustments. One is adjusting for speed, and then the other is adjusting for pressure. And here the desired is what you want to arrive at. This is what you have measured based on your flow rate measurements, and this is the speed that you have determined your sprayer to be traveling, and this is what you are actually trying to target. If you put all of these in, you would find the new speed that you can use to achieve exactly the desired gallons per acre. In the same way, there is also you know, a relationship. This formula would also give you the pressure, the new pressure that would give you the desired gallons per minute to produce the gallons per acre that you desire. And these are additional steps that you can do if you want to arrive at that same one. I was going to look at you know, all these spray definitions, but I will skip this and then just mention the fact that once we are done with all the computations, the next is to assess the coverage and determine what the coverage is, and then we can put water sensitive cars, these yellow cars that turn blue, in different locations of interest within our canopy, and then spray with the settings that we have determined, and then see what the outcome is at different locations. And then based on that, we can do additional adjustments to make sure that the spray is reaching where we want it to go. So with this, let's do this quick poll, and then we will take our break from now.
While they're doing the poll, we have another question. Is there a program for analyzing the spray cards?
Yes, I had that on the, if I go back, there are methods to do that, but there is an app called Snapcard. This is a free app that you can use to do a quick determination of the percentage coverage, and so you can quantify it. I mean, you can do the computation and then determine how it differs, how the percentage coverage differs from point to point within your canopy where you place the cards. Otherwise, you would have to just use visual inspection to compare where how much of spray is reaching one location as compared to the other location. Okay. So I guess if we are done with this, with the poll right now. Okay, let's see. I think the results are good, and it's let's see. The first one, land rate in spray application, is determined by. How about we take the break now? So maybe when we come back, would share this result and discuss that very quickly as we move to our next item. Or we can skip discussing this and we'll take the break and then we can come back at 11:20. So it would be like 11 minutes instead of initial determination of 11:15.
Great.
So let's take the break now, and then be back at 11:20.
Perfect.
Okay. Thank you. Hi, Julia.
Hello.
Do we have everyone back?
I believe so.
I just sent you a document to share with everyone.
Okay.
I was trying to see if I could share it directly here, but I could not find how to do that. So I emailed that to you so you can share with everyone.
Okay, I might have to email it to everybody, but we can do
Okay. Okay, all right, that's. And I'll talk about that one, okay. It will be included in our discussion. Okay, so for everyone, I'm going to continue with this. Can everyone see the screen? We're sharing the poll results, and the first one I would have skipped it, but there is one response which is off, so I would quickly look at that one. It says land rate in spray application is determined by both travel speed and flow rate. So I think this is rather the other way. I think land rate is in spray application is determined by both travel speed and flow rate. This is actually false. Most of you missed it. It wasn't meant to be a trick question, but the application rates, I know we are mentioning a lot of rates. Application rate is, we have the flow rate, which is the sprayer output divided by land rate, which consists of row spacing or the swath width times travel speed. So land rate in a spray application is actually determined by both travel speed and row spacing, not flow rate. Because flow rate is on the top in the and that is where we add. If you read it carefully, you realize that the correct response should be false. And then for 2 says, I think everyone got 2. And okay, so I'm going to skip that to spare us some time. And for 3 says we need multiple choices, so we can look at that one quickly. Which of the following are different ways of adjusting the amount of fan air reaching the target canopy? And we didn't talk about this a whole lot, so but let's see how we did. So increasing travel speed definitely will adjust the fan air that is reaching the target canopy. And if you increase, it's similar to the flow rate. If you increase your speed, you're reducing how much air is getting to the canopy. And if you slow down, you are increasing the amount of air that is reaching the canopy. So that would be one choice. Decreasing travel speed is also one, because it's both increasing or decreasing will adjust it, right? And then adjusting fan air intake would also do. So all these three apply. All these 3 are correct. So I thank you for participating in this poll, and I would have stopped sharing it now. Okay. Let's get back to the presentation here. All right, so we move on, and the break is over here. Now I believe there are a couple of you that said you needed help with installing the the software. I believe we sent out an email describing how to get it done. If you are able to download it through the direction that was sent to you, then you should be able to follow the tutorial video to get it installed. And if there is any help needed, we'll see how to provide that. I don't know if we're able to do that right now. There were 2 people that said they needed a help, and with all the technical hitches, I'm not sure if we would be able to do that now. So we'll go on, but we'll try to extend that help so we can keep everyone in the loop. So look at the this CitrusSprayEx expert system overview. And before I go to the software itself, I just want to give a quick overview here in PowerPoint, and then I would move on to talk about that. All right, so the number of looks like welcome screen here. If you start the program, if you have it installed, if you start a program, this is what you would see as a first screen, which welcomes you with some information, not where you'll be running it yet. And then you click on the spray planning button, and you have calibration and timing. The expert system is at the base divided into these 2, spray planning and then spray evaluation. So the spray planning consists of calibration, which we have discussed, and also timing. And the calibration aspect is supposed to serve as an aid to help you or help a user to do the computations right. The spray timing also provides guidance as in determining whether a combination of weather conditions are favorable or not favorable for spray application. We would have a general understanding of what favorable condition look like, but sometimes you'd have you want to make a more objective decision as to whether a particular timing is favorable or not, and this can help to make that determination. Under the calibration, we have 3 main steps, which are captured in different panes. We have the calculate speed, we have select nozzle, and you have calculate nozzle. So these are different steps that are involved in the calibration. And if you and then also under timing, we have just 1 pane, and it will be discussing as we move on. But let me go on to the program itself, and this is what it looks like over here. Again, you have the spray planning. Clicking on that will give you calibration and timing.
Peter, can you share your screen?
Can you see my screen now?
Yes, there we go.
Okay, all right. I probably will be moving back and forth here. Let me see. I would prefer to share that whole screen and not just a single. Okay, I think this would be most appropriate. All right, the whole. Can you still see it?
Yes.
Okay, thank you very much. So you have the this here, spray planning, and if you click on calibration, you have calculate speed, select nozzle, and then calculate sprayer output. And then, yeah, and then you have, under this, you have different, under calculating speed, you have a non-distance method, a tree-sparse method, and a selecting nozzles. There are all these inputs, which should give you outputs that will lead to selecting the correct nozzle. This would be after you have determined how many nozzles you'll be using, and then the calculate sprayer output would also be used to determine or to help determine what the sprayer output, that is a combined flow rate, is. And then on the other hand, we have the spray timing, which involves entering a combination of weather conditions and determining what the whether it's suitable or not. And then the spray evaluation part, this will be looking at tomorrow, but I just, as an overview, I just showing what is there. It includes various inputs that you would enter to and simulate to give you some outputs that you would help to make a determination. Now, as we go on, I just want to say that this is not a perfect system. The idea of our project is to gather inputs from people as they use this, and also, get a sense of aspects of it that are desirable, aspects that are not desirable, things that, components that can be added onto it to improve it. And in the long run, this is not what the final output is going to look like. We intend to develop a new expert system that would be online and also mobile friendly. So it will be an online application which can be accessed using a mobile device. And these inputs that you see here are going to be some of the base inputs and outputs are going to be some of the base ones that we'll be building on. So if there are components that we think are not useful based on the feedback, we would adjust them to make them more useful to the intended users in the long run. So please, as you engage with this, I would encourage you to take note of aspects that you think could be improved, and would be happy to receive your feedback and use those, incorporate some of those feedbacks into developing the new expert system that we are working on currently. So let's go back to the presentation very quickly. Move to the next move to the next slide. So at this point, we would be going to hands-on demonstration for spray application planning. And Julia sent you a file, a Word file. I would be going through some demonstration, but I would want you to follow along in this demonstration. And the file that was sent to you contains some scenarios that I would want you to do this by yourself and provide the input, provide your answers in the last column. So you provide the answers after you have worked through you have worked with the application. Provide your answers in here. This will tell me that you've actually done it, and it's especially important for those who are working towards continuing education credits. Please work this out, and if you have any comments from using these, you can provide those comments when you do the evaluation. There's also going to be later on a feedback survey on our project website, which you can use. Would invite you to make some inputs in there that would be helpful for us to further develop this system. Okay, so hold on to the Word file. After you have entered all your questions, sorry, I think it's better to. This is the file you should have. After you have entered all your answers in working through these, I would want you to provide your name and your license number if applicable, and then save this as a PDF. If you are able to, I would prefer it as a PDF, and please send it to Julia. She has been communicating with you. You should have her her email number. Turn this in to Julia, and then we would look at that. Okay. So let me get on with the application. Let's see. Here is a scenario that we are going to engage with, and the scenario says you have recently made some adjustments to your air blast sprayer and are planning to spray your citrus orchard, and so you realize the need to calibrate the sprayer. The sprayer has 10 nozzles per side, but based on tree height, you would be using 8 nozzles per side. These are just drawing from some of the concepts we talked about. The orchard has 20 row spacing and 15 feet, 20 feet row spacing and 15 feet tree spacing within each row. And the recommendation says apply spray at 100 gallons per acre. This may not be the real, output that you're using in your application, but go ahead and just work this out. This is math, and it should change with your actual the application rate that you are most familiar with. So you plan to travel at least 2 miles per hour. So this is the equation we are basing this on. And if you go into the application and you make the entries, you would get, the ground speed. Let me make sure that we. So here we are assuming something. Here we are assuming that you have tree spacing 100, and time spent. We use the setting to have a time determined to be 46 minutes. That's 46 minutes to cross that 100 feet. And if you put that in, this is the value it gives you. And one thing that I missed to point out is the top here. You see that we have units in metric and also in English units. In this part of the world, we work more with the English units, the American Standard units. So those are the ones who will be most often be using. So if you put the values in, it gives you, and you click on calculate, it gives you what it should be. And then the other point is using tree sparse method. Here we are changing the values. Let's say we have changed the settings of our sprayer, and then we enter these inputs here, and now we are obtaining a ground speed of 2 miles per hour based on these entries. And the assumption I'm presenting here is that the information provided in the scenario I presented before this does not give everything. So we are making some assumptions here. The first assumption is that we had time spent here to be 46 seconds, giving us 1.5, and we've made other adjustments. And now I'm using the 3-sparse method just to show that we are using that one. We are trying out a different method, and that is giving us 2 miles per hour based on these inputs. And so the next thing is determining the nozzle rate, and you have the tank makes specific gravity. When you start, I think the default is 1.0 or 1.2 is a default value, and yeah, this is what you have as default, and you select English units, and you would make all the inputs here. And once you do that, I also want to point out here that the specific gravity is based on a tank mix that is different from water, but based on our calibration, we basically use water. So we maintain this as 1, and then the rest of the values will be based on the scenario that is presented here. So we are using a ground speed of 2, row spacing of 20, number of open nozzles of 8, and we are assuming that we are applying uniformly from each side. So each nozzle is giving out the same output. And so if you select that, and then you select the operating pressure to be 150, it gives you it recommends the nozzle output. I'll point this out that in the program that you've installed, the comparison part is not working. I think when we finalized that, there was a bug in there, so you can't find that. When I run it, I get it from my output, because I both run it from the installed one and also from the one that we are improving to change to the web-based one. So pardon me if you miss this part, but the output and recommendation part should be sufficient to give you the information that you need to go on. And then I would also want to point out that, so the comparison button here, which would produce this, and the report button, ignore those. Just stay on the calculate, and it would give you the values over here. So this is another scenario here. The inputs are different. We are considering non-uniform spray delivery, and that is going to result in some differences, meaning that depending on the setting, we said 66% of the spray is being applied to the top part, and 33% is being applied to the bottom part. So meaning that this one is non-uniform, and that would result in 2 different nozzles selected for the top part for 4 nozzles, and then the bottom part for 4 nozzles. Okay. So here it says upper nozzles is 4 for the D4, 45, and then lower nozzles D5, 23. Meaning that these are the combinations you'll be using on the sprayer to achieve the desired application rate. So we can do all these. We can make all these selections, and then I would also point out that I recently realized a bug in this particular fixed position method. It's fixed, but in your installed one, most likely that one is not going to give you an accurate value. So I would say stay away from it from now. We would update it and would use the corrected one in the new one we are working on. But I wanted to point out to you, so do not use the fixed position method in the version that you have. Okay, but the known area method, actual area known, row by tree spacing, these ones we did not necessarily discuss earlier on, but these ones are applicable. I would later provide information on this, and I'll share that with you. But for now, I would say that this in yours does not work. So it is one of the things that we'll need to work on. So these are some other scenarios for determining whether the spray timing is appropriate or not. And you have temperature input, you have relative humidity input, you have wind speed input, and then also whether rain is expected in 2 hours or not. And then you use that information. And what I want to point out is that as you work through this, you would realize that if, regardless of how many inputs are filled here, the comments would still give you some output, and the explanation would also give you some output. This comments pane will tell you whether it is suitable or not. And then the explanation will give you additional information why it may be suitable and why it may not be suitable. And so we have this one is, these are some examples that you can see as you make these inputs. Is saying this is too dry, and then giving explanation why it is too, what is going to result, or giving further information based on that output. So, and we have also other ones. So this is supposed to quickly take you through it, and I would come back to the software itself, and then I would say go ahead and work through the ones that I have provided to you, and use that as the your experience through it. And I'm going to go to the chat and see if there are going to be any feedbacks from you. I would try to address any questions if you are bumping into any trouble trying to make these inputs. I'm going to look at the chat, and then I'm going to respond to you based on the questions that I'll be seeing from the chats. So go ahead and work through documents that was sent to you. Okay, so someone is asking about when should we send the answers. We have, according to the schedule, we are ending at 12:30 for today's session, and tomorrow's session we are ending earlier. We are ending earlier tomorrow. So today is ending at 12:30. Some of these inputs are quick, and the output would be quick. So please, I would expect that at the end of the session, or sometime after that, we would be able to make complete the hands-on and be able to submit this. Please submit it to Julia. She has provided her email, and you should have received some emails from her earlier on. I can see some question marks, but I don't know what that means.
Peter, I think we're missing the time-specific gravity number, or I'm misreading the Word file.
The specific gravity is supposed to be 1.0. We are assuming water, so it's just 1. So keep specific gravity in all situations, keep it 1. Ashley, I see your question. Are you perchance using the spray evaluation side? If you are using the spray evaluation side, that is not needed for today's practice. So.
Hello, Peter.
Yes.
I'm missing for the section number C, the spray time in seconds.
Question number which one?
1C. 1C.
1C, okay.
Time measured in A above, okay. The time 36.6. Sorry, I did not see that. Calculate. Great. Sorry. Thank you.
Come again. I missed something in your question. Which one are you missing?
I'm not missing anything now.
Oh, you found it?
Yes. Thank you.
Okay. All right. Thank you.
The spray time. Do you know the spray time?
36.6.
You.
I'm looking at 1B and it says select correct nozzle sizes. Would that be the nozzle capacity in gallons per minute?
No, that would be when that would not be the nozzle capacity in gallons per minute. That should be the nozzle. Let's see. Supposed to be the nozzle that is recommended in the output and recommendation pane.
It says recommended T-jet nozzles and it says upper nozzles NA, lower nozzles NA.
Oh. Yes, if you should choose. Let me look at the question. Which one are you looking? Are you referring to question 1?
Question 1, number B, or letter
Oh,
B.
number B. Okay.
Yeah. And then I just keep getting an error that says increase pressure.
Oh, okay. What pressure are you using?
Well, it says to use 100 PSI.
Okay. And you're not getting anything?
Correct.
Okay. So in that case, go ahead and choose. You can go ahead and choose a different pressure and then just report that in your answer.
Okay.
Do you follow that?
Yes.
You can use the higher pressure and just tell me that you use a different pressure from the 100 psi. So let's say if you use 120 psi, tell me you use 120 psi. So I know you use 120 psi to get your final nozzle.
Okay. Was anybody else having the same issue?
I don't know if anyone is having the same issue. It's okay if you select a different nozzle and a different pressure and just report that you have used a different pressure.
I keep changing the operating pressure from 100. I keep increasing it, and it still keeps coming up with NA.
Okay, so that probably there is one of your inputs that is not correct. Do you mind if I can walk through with you to see what you have entered?
Yes, that's
What do you
fine.
have for your tank mix?
1.
Okay, and your desired application rate?
The default of 1200.
Oh, okay. So that is where you are erring.
Oh, okay.
So it's if you read the question, the application rate is stated.
Oh, okay. I thought that was the default number. Thank you very much.
Okay, all right. You're welcome. So I just answered one question, which is concerning the second part on the spray timing scenarios. The response I'm looking for is just from the comments. No need to include the response from the explanation pane, just the explanation, just the response in the comments pane is what I need.
Hi, Peter.
Yes.
I'm a little bit confused in question 2C.
2C, okay. What's your confusion?
Using the actual, yes. I'm not sure how to calculate one of the required data, the volume sprayed.
Oh, the spray volume. Okay, let me look at that. Do you mean question 1C?
2C. 2C.
2C. Okay. 2C says using the actual. Okay, so if you use that one, what you need is the volume sprayed in gallons.
Or doing the calculation sprayer output. I'm not sure how to calculate that one.
Okay, so this one says that if you go back, it says that the full tank, was sprayed. So you have to go back and look for the tank capacity.
Okay.
What,
okay.
do you see that?
Yes.
Would that be helpful?
Let me see.
Spray time. Then the spray time needs to be from the beginning of the question 81.5 or from the end 40 minutes time.
Oh no, come again, please. I'm missing your question. You said the spray time is what?
Spray time should be 40 minutes or 81.5.
If you look at the information provided here, the spray time should be what has been provided in the directly in that section C.
Thank you.
Because that is covering the entire. Providing you the answer. That is covering the entire forecast. If you read it right.
So how much is it? So it will be 60 minutes.
You need to close the.
I have it too.
Do you follow that? Do you still have questions with 2C? Or has it been clarified?
I am not sure. I'm trying to answer it. I can tell you the answers that I came out with, but I don't know if you want that.
Okay. Maybe for the benefit of all, I'll just read it and explain to you. So maybe that would be helpful.
Please.
It says the orchard has 20 rows spacing and 20 feet row spacing and 16 feet tree spacing within each row. Okay, with 55 trees per row, a sprayer covers 1 acre in 2.5 rows. Okay, so that is giving that information. It's not highlighted because this information I've made it a bit easier to rate it. You will not necessarily be using this information directly, so it's not highlighted. The sprayer has a tank capacity of 500 gallons and 9 nozzles per side. If you come to see, it says that determine the actual sprayer output per side and application rate if the full tank, okay, and the full tank has been provided here as 500 gallons. So you have the full tank. So you already have the volume, okay, the volume that was sprayed out, and that volume was sprayed in this, was sprayed in 40 minutes, covering this number of acres. So you have all the inputs for that particular question. You have 2 from here, and you have 1 from the initial information. Do you see that? Are there other people who are having problems with this particular question?
I'm not sure everybody's there quite yet.
Peter, if we're going
Yes.
it's yours. If we're going to have this tomorrow again, would you mind sending the handout early in the morning so we can print it?
Okay.
For me, it will be much easier to have it printed,
Oh,
instead of coming back and forth from the Word file to the Citrus.
Okay. All right. Yes. Yeah. Okay.
Thank you.
What can we can do so it will expedite things.
Thank you.
The only thing is we would because we are counting for the time, we would want you to be able to sit in. So that way, this particular portion, if you are holding on, if you receive it ahead of time, sort of like jumping the gun. So
No, but I understand that, but for me it will be much easier if I have the numbers printed and I can see the numbers instead of having to go back or share screens between the Word and the software.
Okay, all right. How much time before the start would be helpful for you?
Maybe during the break I can print it.
Oh, maybe during the break.
I can print it during the break.
Okay, tomorrow's hands-on would be earlier in the day. So
half an hour before we meet?
Maybe some 30 minutes to the time, or maybe, would that be useful?
Yeah, that would be great.
Okay, all right, we'll look at that.
Thank you, Peter.
You're welcome. So we are nearing the time we would adjourn. We would be adjourning at 12:30, and I would want to just ask if there are some of you are facing any particular challenges with any of the questions here. If you're done with it, I would encourage you to explore and make changes and try different aspects and see what you can learn from that. And based on that too, I would hope to get some feedback from your interaction.
For number 2C,
yes.
For the volume sprayed, do we use the 500-gallon tank size?
Yes, that is what the information is telling you. It says the full tank was sprayed. So that is what you'll be using.
Okay, thank you.
I said I've been receiving a couple handouts so far, so people look like they're finishing it up.
Okay. Okay, all right. I understand that most of you or some of you are submitting your work through, so that is a good thing. I'll say thank you to you, and looking forward to continuing this and completing it tomorrow. Tomorrow we'll be looking at the spray evaluation part.